Hello students, I am Dr. Tanmay Vishwas. I welcome you all in my channel Chemistry and History of Molecules. So today we will discuss a MCQ. It's a very famous example. I know majority of you may know. So if you know, I suggest you answer what is the product. Okay? And so first of all, we will discuss how to answer this, and secondly, I will explain how to get the answer, what is the logic explanation behind the process. Okay, so I suggest you try, pause the video and try by yourself. After that I will explain. I expect you have tried. So I shall explain. First I shall explain very fast what is the product, and second I will provide details explanation. And I have a small request before going to the details. If you really like my teaching, please help my channel to grow. So let's start. Actually, this reaction, okay, such type of MCQ could be useful for the exams like CSIR-NET, GATE, IIT-JAM, B.Sc, M.Sc, BSMS, or equivalent exams. Okay, so please read it sincerely. So this reaction similarly is similar type of Luche reaction, but I will not recommend that this is Luche reaction because that is a specific reduction of carbonyl from alpha beta unsaturated carbonyl compound. Okay, but reagent is same. Okay, so let's this example you will find in the Luche reaction application. So what is happening? This is a reduction of carbonyl using sodium borohydride. This is the reducing agent. And this is the Lewis acid. Okay, before let me give you the answer. What is the answer? Among these, the right answer is this. You may be confused that there is aldehyde and ketone. Why selectively ketone reduce, although aldehyde is intact, and this is not proton protected. If it is protected, then it's fine, but not protected. So that is the beauty of this reaction. So this is the product. Now I will come to the explanation how this is formed. Okay, so that's why this reaction should be learned. See, generally when we explain such type of problem, selective reduction of ketone, what do we do? First time we protect using acetal protection, then we reduce, then we deprotect, 3 steps. But this could be done 1 step. So this is the beauty of this reaction. So by the way, I have already uploaded lectures about protection, deprotection of carbonyl, that is, and stability of acetal, hemiacetal in acid and base. You can visit if you have any confusion regarding the concept or understanding. Okay, now let's go. So what's happening, what unique thing is happening in this case such that selectively ketone is reduced. So I should write the product. Means this is. Now let's explain. What happens? See, cerium 3+. It is a reducing agent product. It is a Lewis acid, and actually this is playing the key role for this process. If you don't use cerium chloride, first preference is aldehyde reduction, second is ketone reduction. Why? Because we know the aldehyde is less bulky because of this hydrogen, whereas there is an alkyl group. So this, and second, this has a plus I effect, whereas these don't have. Consequently, this carbon is electrophilic. So steric as well as electronic both support the reduction of aldehyde before the ketone. Okay, for now. So what happens? Methanol, cerium chloride, sodium borohydride. What happened? It's a Lewis acid. So cerium 3+ first time coordinates with the methanol. So it should look like this. This lone pair is coordinated to the central cerium atom. Okay, so if this lone pair is coordinated, means the oxygen has some electron deficiency on it. Fine, because oxygen is electronegative. It has given its electron to someone. So definitely it has electronegative. So consequently, this polarization will increase. My purpose to give double delta is to show that some increased polarity compared to simple methanol. Okay, this is also delta plus, but a little excess. So what is the advantage? See, sodium borohydride. Please keep this information in mind. Sodium borohydride is stable in methanol. means it doesn't react. Please keep this information in mind. So cerium what is doing? Because of this enhanced acidity, now sodium borohydride is capable to react with this. How? If you see the borohydride, it looks like this. This hydride is delta minus boron. Actually, better to say this boron is saturated. Overall, if you think that hydride, so this is delta minus. I'm not going to the complication. So this is the hydride. This is the proton. So what is expected? That both of them will react, means react and remove as hydrogen gas. So if it is eliminated the hydrogen gas, what is left? Consequently, the product is, this is the boron, this is hydrogen, 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 this is OMe. Why I am writing this? See, it became an anion right now, and after removal of this, what boron is converted? This is converted into BH3. Previously, this is 8 electron species, but right now it's a 6 electron species, electron deficient Lewis acid. So consequently, this alkoxide comes and binds with boron. Now, what is the profit of this process? Still, it is a negative charge. Fine. See, boron has an electron-rich oxygen, and we know when boron and oxygen has together, oxygen pushes electron to boron. Consequently, the migration tendency of hydride increases. Okay, and this hydride migration results in carbonyl reduction. Okay, till now, from this understanding, we understood that we have prepared an active borohydride. Fine. If we have prepared active borohydride, then we can expect both will be reduced. Simple logic. But that's not the complete story. So this is one part of the work. Second part. See, these oxygens, they have lone pairs also, and cerium is a Lewis acid 3+. So it can coordinate. So what happens if you see these versus these coordinates better way? See, bulkiness is less. So if the ligand is less bulky, it is easy to coordinate. That is happening here. So first time, cerium first preference is this. So this, let me show in this way. This is coordinated. Fine. So if it coordinates, the electron density on oxygen reduces, similar reason. So consequently, this carbon's electron deficiency increases. And you may think a canonical form that this bond go up and it became plus, and this minus which is neutralized by the cerium 3+. Fine. Now, what happens when the electron deficiency increases? It results into the formation of acetal. Okay, acetal or hemiacetal, whatever you can say, but it results in the sp3 carbon formation. Okay, so this acetal formation, what ultimately result? So this and this will result in this acetal formation. So CHOMe, OMe acetal, because there is methanol as solvent. Fine, alcohol, OMe. Now see, it's a blocked. What protection chemistry we generally think we have achieved in situ. Fine. And in the next step, what is expected? The cerium, second time, it can coordinate here also. Now you may consider, sir, why you are showing coordination here, not here? Whenever needed, you are showing that. It's not like that. Actually, coordination possible for every case, but where it is more efficient, because it's an equilibration process. Okay, equilibrium tendency is more for this than this. So it will be coordinated. Now this center became more electrophilic, and this hydride is migrate and attack. Okay, so this hydride migrates and attack, and what it result? It result in the O- formation. This is the hydride, and here the 5-member ring, and this is CHON. Okay, so this, and later it converted into this product during the workup procedure, because when you use sodium borohydride type reagent, it is essential that you should quench, and generally you can use slight amount of acid in order to quench. This will break during that time, and this will also break, and ultimately this will be OH. So this is the product. So I know it's a very interesting, it's a well known, but I believe students may have some lack of understanding, and that I have tried to clear in this video. Okay, so this is the end of this discussion. We have learned about the, first of all, solving one MCQ. Second, learn the selectivity of this cerium chloride sodium borohydride in methanol combination for the selective reduction of ketone in presence of aldehyde, keeping the aldehyde intact. Okay, so this is the end of this discussion. Thank you everyone for listening. If you really like my teaching, I request you please help my channel to grow. First of all, subscribe my channel Chemistry, the Mystery of Molecule. Please press the bell icon to get the notification of every single video, and please press all notification. Okay, because generally I prefer to upload on a regular basis. If you don't, then you may miss, and next day we will find more videos. So difficult, because everybody has 24 hours a day for them, and you have to sleep for 6 to 8 hours. So see how much time you left. So that's why it is better you should finish your regular job on a regular basis, such that you do not have any pending burden. Okay, so this is, and share this video among your friends such that other could be benefited, and I will be happy, because my effort is useful for many people, and most importantly for my satisfaction, please like the video and make some good comment, because it encourages a lot. I can't explain, it encourages a lot. So thank you again, stay happy, stay blessed, see you in my next video.